Let's look at an example where we're trying to find a cube root of a complex number. Example, find a cube root of -4 root 2 plus 4 root 2I. And we're trying to find a cube root. Okay, so we're going to do the same thing. We are going to put this into polar form. So I need polar form. Then raise to the, what power do I need here? Cube root, 1/3 power. So raise to 1/3 power for a cube root. And then back into rectangular form. Okay, those are our steps. Let's do it. Number 1, polar form. So I'm going to say, let's call this Z. Call it anything you want. Okay. What do I need here? A graph usually helps, even just to kind of nail down what quadrant I'm in. So -4, okay. So over and then up the same amount. And I'm in quadrant 2, so I'm going to have some r and then some theta. Let's find those things. So r squared is -4 root 2 squared plus 4 root 2 squared. Again, you're just taking the real, those real numbers a and b from your complex number when you're squaring. Okay, because this is, right, we're calling this like a plus bi. It's corresponding to the point a comma b. So we're just taking those pieces of the number. Okay, when I do that, I get 16 times 2 plus 16 times 2, 32 plus 32, 64. So r must equal 8. All right, what about tangent? Well, this is a nice one, right, where I can see that the theta is going to be 3 pi over 4. So I got that, okay. And now I'm ready to go ahead and do, let's see, step 2, which is find z to the 1/3. Gotta be careful, z to the 1/3 doing a cube root. Okay, oh, let's finish up part 1 by actually writing my polar form. Z is 8 times e to the I, 3 pi over 4. Okay, so if I want z to the 1/3, I just take that and I raise that whole number to the 1/3 power. Okay. So what is that going to give me? Well, let's see. I get, there we go. I get 8 to the 1/3 times e to the I, 3 pi over 4 times 1/3. 8 to the 1/3, that's just 2. E to the, let's see, these 3's just cancel. So it leaves me e to the I, pi over 4. All right, not too bad. Then, let's see, this is my z to the 1/3. For step 3, it says, okay, turn your new z to the 1/3, which is the cube root, which is what I want, back into rectangular. So z to the 1/3, we just said was 2 times e to the I, pi over 4. But now I want to turn that into my trigonometric form first. So 2 times cosine pi over 4 plus I sine pi over 4. Here's my 2 is still hanging out there. Cosine of pi over 4, root 2 over 2. Let's see. Plus I sine of pi over 4, root 2 over 2. This gives me root 2 plus I root 2, which I can also just write as root 2 plus root 2 I. And so there is my cube root. If I wanted to check it, I could multiply that by itself 3 times and see if I got my original number back. But it's a little more arduous with more steps there, but that would be a possibility. But that is how you find a cube root of a complex number.